Yeah. In the data storage capacity, we are here discussing two types of things, like two major types of unit, which is the bit and the byte, which we are using frequently when we are addressing the capacities of a computer. And bit is known as the smallest unit of the data, right? Which which we are used like when it comes to the human body, we say the cell is the smallest capacity, the smallest unit that we are referring to the human body. Likewise, when it comes to the computer, we say the bit is going to be the smallest unit of the data when we are talking about the storages, right? So bit is abbreviated by the word binary digit. You can see how the bit is happen, B from the binary word and IT from the digit word. So that is how they form the bit, the word bit, right? And this bit indicates the 0 or a 1 in the computer, right? So now you can understand, like when it comes to the binary number system, it is the exact similarity. There is exact similarity in between the bits and the binary number system, because binary number system is having only two units, two characteristics, which is 0 and 1. Again, when it comes to the bits, it can indicate two units by it, which is a 0 or a 1, right? So actually two values, right? So then when it comes to the bytes, nibbles, and kilobytes, megabyte, gigabyte, there are some relationships in between, right? So if you think about a byte is made out of 8 bits. When 8 bits are taken together, we call it a byte, right? And there is a unit called nibble, which we are not very much used, but it's better we get to know about it due to the exam purposes, right? So when we collect 4 bits together, we call it a nibble, right? But we are not very much using that particular unit. So thereafter, you may have heard about these things, right? The word kilobyte, the megabyte, gigabyte, even terabyte, you may have heard, right? Sometimes you may not very much familiar with the petabyte, right? But today I'll tell you what are the connection in between these units. Like when it comes to the gram and kilograms, you know what is the relationship between those two, right? So 1 kilogram is equal to 1,000 grams, right? So likewise, these bit, byte, kilobytes, megabytes, they have their own relationship with in between those things, in between those units, right? So let me illustrate it like this. Now if you go through the notebook, you can see as we discuss, a one byte, a one byte is consist of 8 bits. So we can consider it, or like we can illustrate it like this, right? So I have taken bit as the smallest unit right over here, right? So like here, when I'm illustrating a byte, I take 8 squares, like the similar size of 8 squares. So together it illustrate a byte. And again, when I take 4 squares together, where a 1 square indicate a bit, it indicates a 1 nibble. But then after, from byte to kilobyte, from kilobyte to megabyte, from megabyte to gigabyte, and from gigabyte to terabyte, and finally from terabyte to petabyte, right? It has a relationship of 1024s, right? So this indicates 1024 of bytes will indicate or will equals to a 1 kilobyte, right? From this point onwards, same relationship continues. So 1024 kilobytes is equals to a 1 megabyte, and 1024 megabytes is equals to a 1 gigabyte, and 1024 gigabyte is equal to a 1 terabyte, and 1024 terabytes is equal to a 1 petabyte. So that is the relationship in between these units, right? So it's better you know about these things, because there can be some questions asking about like what are the relationship, or like they can ask like what is the capacity of 2 kilobytes in bytes, right? So you have to like multiply 2 by 1024 to take the total amount of the bytes, right? So simple as that. Okay, people, is this clear? Is the diagram is clear with you? Yes, everyone? All right, great. So let's have this into our notebooks, right? So first of all, it's better you say, yeah, you really don't need to write about this data storage capacity and all these things. You can go with this. Units to measure data storage. That's going to be your topic. And it's better you write about bit, byte, and the nibble, right? So once you are done with it, let's go for the diagram, right? Let me know when you are done. Oh, Dihan, highlight කරලා තියෙන ටික තමයි copy කරගන්න ඕනේ. මේ binary digit කියන එක highlight වෙලා නැහැ. ඒකත් දාගන්න note එකේ ඒකත් කොටසක්. All right, one is done. How about others? Okay, right, great. Can we move? Is there anyone still writing this? Oh, okay, okay. Epa, Dihan, kilobyte liya no nebude. Right, can we move? Right, okay. So I hope there is no one is writing anymore, right? Just let me know if you are doing that, right? Okay, so you can copy this down.
So we have to copy the whole page.
Yeah, the whole thing. Yes, yes. Like when you are writing this 1024, just write it like it belongs to the all each and every unit over here. So make sure it covers all the units. අවදිහාන් මේ තියෙන ඔක්කොම ටික ඇඳ ගන්න ඕනේ. One is done. How about others? All right, two are done. Others, hurry up. All right. Is there anyone still writing this? Okay, so let's move on. Right. So next is about, now this table, we are not going to write this table, but it's better we concentrate of what they are saying is just a comparison and saying how it happens, or like it compares with the things in the real world, right? So like they are asking us to think like byte as a one text, right? So kilobyte is equals to half of a page, like text which spread on half of a page, right? And megabyte is equal to 500 pages, and gigabyte is equal to 500,000 pages. And look at the terabytes, it's like 5 billion, right? Yeah, is it the billion or like half a billion? Yeah. This is million, and this, yeah, it's kind of a half a billion, right? So like 500 millions pages, right? And again, when it comes to the bytes and other units comparison, so like if they take it from approximately equals to the thousands, right? So it's like kilobyte is equals to 1000 bytes, and megabytes equal to 1 million of bytes, right? And gigabyte is equal to 1 billion of bytes, and terabyte is equal to 1 trillion of bytes. So like the modern hard disks, they contain 1 trillion of bytes, right? So just to have that comparison, like have the idea how big the unit that we are talking about, right? So with that, we are going to move to the next topic, which is talking about the storage devices in the computer, right? Now, when it comes to the storage devices, here they are talking about the capacity, as well as they are going to talk about the access speed, as well as the cost per unit, right? So when it comes to the capacities, as you can see in the chart, they are talking about the registry memory. The register memory is the memory that we found in the inside the CPU in the von Neumann architecture. You can remember, like when we are discussing the von Neumann architecture, we discussed three components inside the CPU, which is the control unit, arithmetic and logic unit, which is the ALU, and the register memory, right? So that register memory is the smallest storage in our computer, which stays inside the CPU. So then after the cache memory, now in modern CPUs, cache memories are inside the CPU, like the register memory. But Generally we say register memory is in between, generally we say cache memory is in between the registry memory and the RAM, right? So cache memory is a little bit bigger than the register memory. As you can see, like register memory comes with kilobytes, cache memory comes with megabytes, right? And then after the cache memory, they consider the compact disks, the CDs, are the next largest storage. So which is an external storage, right? Not an internal one. Registry and cache memory both are considered as internal storages, right? Compact disk, it is a secondary storage or external storage, which is 650 to 900 MBs. We discuss about these things. Then the digital versatile disk, the DVDs, from 4.7 to 9 GB. And then it comes the random access memory, another internal storage, and we call it as the main, we call it as the main memory as well, right? Dihan, cache memory, we discuss about that in the second lesson, Puta. So like cache memory simply does, it remembers things which has been executed frequently, right, in the CPU. So generally, if the CPU need to execute something, it has to refer the random access memory, but cache memory is in between the CPU and the random access memory. So before CPU refers the RAM, it refers the cache memory to see whether that particular program is in the cache. So if it is there, it will take, or it will refer the program from the cache memory. So as a result of it, the execution time of the program will be less, or like the program will be executed quickly due to the cache memory, right? And random access memory, we can find those things from like in gigabytes, right? Earlier in my school days, I remember I had 256 megabyte random access RAMs and 512 RAMs, and 1 GB RAM was at that time, it is a huge one, right? But these days, it starts from 2 GB and as well as 4 GB, right? And goes up to like 64, sometimes it goes up to 128 as well, right? And this ROM, the read-only memory, it is not a very good place to have the ROM over here, because when it comes to the ROM, it differs from ROM of a computer and ROM of a mobile device. It has different capacities, right? Actually, the ROM is not a very good place to have it here, but I think they have placed it here by considering the ROM of the mobile devices as well, because mobile devices ROM is rather big. Actually, for mobile devices, when we are like referring as the memory, we are referring to the ROM, right? So maybe because of that, it is been placed over here, and maybe it is the reason that they haven't specified the capacity specifically over here. For just for our syllabus, let's keep that in mind on this particular order, right? Then the flash memory means the pen drives and all these things, right? And the micro SD chips and all these things, they are comes in the range in between 1 to 64 GB, right? And hard disks, yeah, they are the main storage devices that we can find in our computer system. It goes from 100 GB to the 6 GB, like now it's beyond the 6 GB as well, right? And the very last one is called the magnetic tape. So like magnetic tape is not very much used generally by us, right? But for some special purposes, like in film industry, in recording industry, or like the audio engineering industry, right? Sound engineering part. Sometimes they use this magnetic tapes to record the high quality data, which has this ability of storing things in between 1 TB to 185 TBs, right? So yeah, so that is those kind of things. Yeah, Ranuja, ROM, you are going to learn about the ROM in the fifth lesson, operating system lesson. It is in a computer, ROMs are the things that help us to boot the computer, right? Computer ko on වෙනකොට කරන්න ඕන දේවල් වලට උදව් කරන්නේ ROM එක, right? You may ask about, you may heard about the terms like CMOS, BIOS. Those are ROM type of storages. We'll discuss when it comes to that point, right? All right, so people, it's better you remember this order, right? These things are tested in the multiple choice questions, MCQs, right? And definitely you may have one of the similar kind of questions, right, in the future. So yeah, so let's take this down, have the subheading, capacities of data storage, and it's better you copy down the list, and you don't need to draw this ant and the elephant, right? If you really want to draw it, you can draw it at home, right? And but have this arrow kind of things, right? And mention the smallest capacities at the top and the largest capacity is at the bottom, and write down this order and the with their capacities, right? Okay, so
So we can turn zero to top the bottom.
didn't get you, Puta. Yeah, come again. I didn't get what you were saying, Puta.
So we can turn the arrow to top the bottom.
Yeah, but if it happens like that, the list will go from top to bottom again, right? Right. So they are talking about like this from smallest storage, from larger storage to smaller storage. That is how the directions that they have given, right?
So what is the heading?
Yes, මට පුතා අහන ප්‍රශ්නේ මට clear නෑ.
So what is the heading?
Yeah, heading is going to be like this: capacities of data storage, and copy down the data storage with the arrow. ඔව් දිශාන් මේ තියෙන විදිහට කොපි කරගන්නකො පුතේ. All right, one is done. How about others? All right, is there anyone still writing this? Right, okay, Ranuja. Right, are we done? Okay. All right. So the next part is about the data access speed. Now, data access speed means how fast the data can be getting to these storages, right? So like lesser the time will make it more speed or like more faster, right? So when we are considering that, register memory has the fastest or like the largest access speed. Actually, it's the fastest one, right? And cache memory is comparatively slow to the register memory, and random access memory is comparatively slow to the cache, right? Likewise, ROM, flash memory, hard disk, and it goes likewise, right? So the magnetic tape is the slowest. It has the slowest data access speed, right? So with the access speed, there is another factor always binded with it, is the access time. So when the register memory has the fastest access, or like when it is doing the when it has the largest access speed, the time that it takes to have the data is the lowest, right? වැඩිම speed එක තියෙන කෙනා තමයි අඩුම කාලයක් ගත කරන්නේ, right? So it goes like that, right? So it's better you concentrate on that as well, right? The one who is the fastest has like spending the lowest time to take the data, right? Okay, so the task is very simple. Have the data access speed, the heading, and copy down the list with this arrow as well, right? Indicating who is slow and who is fast. Right, one is done. How about others? Okay, is there anyone still writing this? Yes, is there anyone still writing this? It seems not. So we can go for the next topic, which is the cost per unit storage. Right now, when it comes to the cost per unit, now it says register memory has the highest cost and the digital versatile disk is the lowest, as they mentioned, right? And yeah, Ranuja, we have discussed about these things, Puta, in the when we are doing the second lesson. It's better you refer the recording, Puta, right? So when it comes to the register memory, as I told you, the register memory is inside the CPU, right? So if in case if we want to replace the register memory, we won't be able to replace only the register memory. It is the entire central processing unit, that chip has to be replaced, right? So central processing unit may cost you like 30 to 40,000, right? So that's going to be a problem, right? Since it is a big money. So again, since the register memory's capacity comes with kilobytes, so for some kilobytes, you pay 40,000 or like average, let's say 30,000 rupees, right? So that is for kilobyte. If we are doing the calculation for byte, we are going to divide 30,000 by 1000 approximately. Actually, we have to divide it by 1024. But if we divide it by 1000, so it will be 30 rupees per byte, right? And per bit, to find it per bit, byte is equals to 8 bits. So approximately, like when 30 divided by 8, so it approximately cost you 4 rupees, right? When you are thinking about the cache memory, it comes as megabytes, the capacity. Now the cache memory, that is either in the registry memory or in the on the motherboard, right? So if you assume generally it is on the motherboard, so motherboard will cost you like 15 to 20,000, right? So here a megabyte cost you, some megabytes will cost you 15,000, right? If you do the math, once the 15,000 divided by 1000 will give you 15 rupees, but that is per kilobyte, right? So if you are going to calculate this per byte, again you have to divide 15 by 1000, which will cost you like 0.015 rupees. Sataganak again, right? So this is the cost per byte. Make a bit make a ayat atem beden noni, right? So if it goes like that, it's going to cost you like 002 rupees, like satayenut tapunchi kotasak, right? So this is the cost per byte for cache memory. This is the cost per byte for registry memory, right? So you can see the highest cost is contained by the registry memory. So when you are going down towards this list, the capacities of these components are being increased, right? So like when it comes to the random access memory, it is from gigabytes. Read-only memory, actually, this is, as I told you earlier, right? This can be in megabytes or gigabytes, right? And when it comes to the magnetic tape, we saw it is from terabytes. Flash memory, it is again from gigabytes. Hard disk from terabytes. Digital versatile disk, that is from gigabytes, right? So if you think about the costs, random access memory will cost you like, yeah, 10 to 15,000. Sometimes you can find it like less than 10,000 as well. Read-only memories, yeah, and now this is a little bit doubtful, right? When it comes to the mobile phones and all these things, again, it will cost you like 10 to 15,000, right? And magnetic tapes, it is a special thing still. It won't cost you this much, right? It will cost you like more than this, but since it is the capacity is big, again, the calculation will give you something lower like this, right? So when it comes to the flash memories, you can purchase a pen drive for like 1,000 rupees, 2,000 rupees. So I'll take 1,200, right? So some gigabytes will cost you 1,200. So you can do the math how cheaper the cost is going to be per bit, right? So because of this reason, the highest cost is taken by the registry memory per bit, and the lowest cost is taken to the digital versatile disk, which is the DVD, right? When it comes to the CD, it's going to be much lower than that as well, right? You got the point, people? Is that clear? And Ranuja, if you cannot get the things that I have said in the recording regarding the CD and DVD, just remind me to tell what are the differences, Buddha, right? Because it will take some time. Right. Okay. So let's get this down. So here comes the topic, cost per unit storage. And as usual, just copy the list down with the arrow. One is done already. So others, be quick. Okay, another one is done. Okay, is there anyone still doing this? All right, let's move forward. So next is about the coding systems. Now this indicates or this describes how the computer what are the ways that the computer has used to represent its characteristics from the very beginning, right? So you know, at the very first era, in very old days, when the computer was like big as a house, right? They were used this to do some major calculations. They were used this to do some major calculations, right? So it is always value based, like uh, not text were involved, right? So the very in the very first era, they have to deal with, or they have to come up with a solution to represent the numbers in the computer, right? So for that purpose, they have used a particular coding system called BCD, binary coded decimal. So the method or the technique that they have used is very simple. We know this already. You remember the way that we have represent a particular character uh, in binary when we are converting a hexadecimal value into a binary. So when we are converting a hexadecimal value into a binary, the thing that we have done is we've taken a character from the hexadecimal and we represent it using 4 bits, or like 4 ones and zeros, right? So the similar technique they have used, but here they are not representing the hexadecimal values. Instead of that, they are representing the decimal values, right? So this is the way they have used this, right? And if you want the clarification, right, we know how to get the clarification over here, right? If you think about one particular value, the decimal value, you can represent a particular decimal value, and you are going to represent a particular decimal value using these 4 bits. So these 4 bits can contain the place values like 1, 2, 4, and 8, right? So the only thing that they have done is they have created a code which represent the decimal value. Now, like if you want to represent 5, so how we are going to make 5 from these things? Like 1 over 4 and 1 over 1. So 4 plus 1 will give you 5, and rest of the places will indicate 0. So that is why 5 indicates 0, 1, 0, 1. Right? If you want to indicate 7, you are going to take 4 plus 2 plus 1 and nothing with the place which indicates 8. So that is why it comes like this, right? So likewise, they have used this technique to indicate decimal values or the numbers or the characters in decimal number system as the BCD values, right? So in case if you are asked to represent 27, the decimal value in BCD, what you are going to do is you are going to write 2 as 0010 and 7 as 0111. So this is going to be the answer of the decimal value 27 in BCD. Yes, Dihan, what is the point that you can't understand BCD, Puta? Dihan, mic එක on කරගන්නකෝ. කොතනද පුතේ තේරෙන්නේ නැත්තේ? All, you mean like, හරි, Dihan අහගන්නකෝ. BCD කියන එක පාවිච්චි කරේ කම්පියුටර් එකේ decimal values, කියන්නේ දශමයේ සංඛ්‍යා නිරූපණය කරගන්න. right? එතකොට 10 පාදයේ සංඛ්‍යා තියෙනවනේ මෙහෙම බිඳුවේ ඉඳලා 9 වෙනකම්. ඒවට ගැළපෙන බයිනරි වැලියු එකක්. කියන්නේ බිඳු සහ එක පාවිච්චි කළා. මොකද කම්පියුටර් එකට තේරෙන්නේ ones and zeros නේ. ඒක නිසා බිඳු සහ එක පාවිච්චි කරලා ඒගොල්ලෝ කෝඩ් එකක් හදා ගන්නවා. එතකොට ඒක හදාගන්න ඒගොල්ලෝ බිඳු සහ එකේ ඒවා හතරක් පාවිච්චි කරනවා. ඒ කියන්නේ ස්ථාන හතරක පාවිච්චි වෙනවා. ඒක ක්ලියර්ද පුතා? දිහාන් දිහාන් මාව ඇහෙනවද? right. එතකොට ගිහන් අපි මේ එක කැරක්ටර් එකක් මේකේ විදිහ තමයි මේ විදිහට places හතරක් පාවිච්චි කරලා ones and zeros වලින් represent කරන එක. දැන් දිහාන්ට මතකයිනේ අපි place values ගැන කතා කරා binary number system එකේ. මේ 1 2 4 8 කියලා කියන්නේ first four places of the binary value. right? එතකොට මේ places හතර පාවිච්චි කරලා මේ binary value එක ලියා ගන්න විදිහ ගැන තමයි අපි කතා කරේ. දැන් clearද? කොහොමද පහ හැදුනේ කියලා මේ 0 1 0 1 වලින් පහ හැදුනේ කියන එක? okay. දිහාන් දැන් ඒක හරියට මේ වගේ මට හිතෙනවා මට මේක ප්‍රැක්ටිකලි යෙදෙන තැනද ඔයා අහන්නේ. දැන් ඔයාගේ keyboard එක ගැන හිතුවොත් if you think about your keyboard has many different characters, right? So at the very first day of the lesson of number system we talk about what happens when a particular key is pressed and how it is going to indicate or like how it is going to identify by the CPU, right? In the old days they didn't had this much of keys in their keyboard, so it was only numbers. So what they have done is they made this BCD to say to the CPU which number has been input or which number has been referred by the user, right? එතකොට ඒගොල්ලෝ වැඩ කරේ ඉලක්කම් වලින් විතරයි. So it's like a keyboard is having only the keys from 0 to 9. So when 0 is pressed, this 0000 code is hit on the CPU. So CPU understands once the 000 code is hit on the CPU, it understands, okay, the user has pressed the key 0, right? Something similar to that. Did you get that? Right, okay. All right, so let's write down about the BCD, right? So have this heading, coding systems. Right, then
So the
you
main
can,
heading is coding system.
yeah, the main heading is coding systems, and you don't need to go through this explanation over here. They are just giving the general explanation. So you can straight away write this subheading, BCD, binary coded decimals, right? Then you can copy this, yeah, from here to here. Plus we have to copy the table as well. So first copy this, then we'll move to the table. ඔපතේ කලින් highlight කරපු එක ලියන්න ඕනේ. අපි කලින් highlight කරේ coding systems, right? Under that you are going to write binary coded decimal. All right, so if you are done, you can go for the table, which is this one.
So please show it.
Right, okay, right. So if you have the textbooks, just copy this and the example as well, right? I'll keep this since there are some people still writing this. If you're done, go for the table in the next page, right?
Okay, sir, thank you.
Right, okay. So copy this with the example. Inupama, copy down the example as well. Right, okay. Okay, 2 are done. How about others? All right, Litira, මට මතක් කරන්න මම කියලා දෙන්නම් ආයි. Right, is there anyone still writing this? රුසිරු grid එක කියලා කිව්වේ මොකද්ද පුතේ? Table එකයි example එකයි දෙකම ඕනේ. Right, is there anyone still writing this? Right. So moving to the next one. Now, in the very first era, or like with the initial computers, even though they had this requirement to work with the numbers. All right, okay, right, okay. Rosira neve එහෙමනම් කවුද මගෙන් අහලා තිබේ? Dihan. Yes, Dihan grid කියලා refer කරේ table එකටද? Table එකයි example එකයි දෙකම ඕනේ. Right? Okay, okay. Right. So since the initial need was the numbers in the computer, but with the advancement, or like when the technology is improved over the time, they had this need to get more characters into the computer, right? So first they had the numbers from 0 to 9, then they have to involve with the letters and the all these punctuation marks like apostrophes, full stops, exclamation marks, and all these things, right? So any character requirement means you need a unique code, right? Now, if you think about the maximum number of codes that you can have with BCD, it's going to indicate you 16, right? මේ වගේ එකිනෙකට වෙනස් කෝඩ්ස් 16යි අපිට bit 4ක් පාවිච්චි කරලා ලියා ගන්න පුළුවන්. Right? Now that can be calculated by taking the number of bits as a 2 to the power. Right? So you have 4 bits over here. Right? You got 4 bits inside this code. So number of combinations, like the maximum number of combinations is going to be 2 to the power 4. That means 16, right? But if you think about the letters, the English letters in the alphabet, they must need 26 unique codes for the capital letters and 26 unique codes for the simple letters. So there you get 52 already. So the BCD representation was not enough anymore, right? So because of that, they had to search for something big, or like a code system which can illustrate more characters into the computer. So the solution was extending the number of bits inside this code. So like, without keeping it as 4, they have to extend like further than 4, like beyond 4, right? So the next stage was, or the next proposal was, using the code with 7 bits to represent the characters. So with 7 bits, that code system is enables 2 to the power 7 different codes to indicate the characters. That means 128 different codes are there to deal with the characters. So it was sufficient for that time, right? So 128 different characters means you can represent all the characters. It needs 52, 26 plus 26, and you need 10 for numbers. So 56 plus 10, 66. And you can use rest of the things for the punctuation marks and all these things, right? So on that time, it was enough for the requirement, right? So the code with 7 bits has given a name as American Standard Code for Information Interchange, right? In short form, we call it ASCII, right? And ASCII code was introduced by the American National Standard Institute, or by ANSI, we say, right? So that is how the ASCII code is represented over here. And there is a specialty inside the ASCII code, that with that specialty, we are given some questions to do so, right? So I'll tell you the specialty here. The specialty is like this ASCII code is happening for characters in an order. Like if you take capital A represent 60 in ASCII code, capital B represents 61, capital C represents 62. So it goes with the exact order, or like in an orderly manner, right? So in your examination, you will be getting these kind of questions, like saying what is the number of the particular letter, or the ASCII code of a particular letter, and you will be asked to create the ASCII code for a particular word, right? So you should be able to identify what are the ASCII codes or the ASCII values regarding other letters. We'll do some examples. So with that, we will be able to recognize what are the ASCII code for a particular word, right? So first, let's get to know, like, write about the ASCII. Then we'll move to the calculation part. I'll show you how it happens, right? So copy down the topic, as well as, yeah, yeah, it's better you go with the entire thing. All right, one is done. How about others? All right. So, okay. Is there anyone still writing this? Okay. Let's move to the Dihan. You are still writing. Okay. Okay. Hurry up. Right. Are we done? Can we move to the other part? Okay. Right. So this is the example which explains what I have said to you. Right. So what they are saying here is like when the word school is entered into the computer through the keyboard, write down how it is understood by the computer. Right. So they say use appendix table 3.7. So the table is like at the end of your note, end of your lesson, right? Right over here. And we are going to find the code for school, right? So that means we have to find the word S in ASCII character, right? So let's search how the S is going to represent over here. Yeah, still, yeah, here comes the capital letters. This is the column of the ASCII letters. So it has the capital letter S, which is this. So the decimal value is this. So S is over here. This is the decimal value. And people, you don't need to remember these numbers in the examination. They are going to give you a number. According to that, you are going to do the representation, right? So first we find the code of the S, which is 083, right? And Dihan, no, we haven't done the seventh one, Pudha. Right? Seventh is the Excel, no? We haven't done the Excel yet. Right? So S is belongs to 83, and you can see in the example, they have taken 83, right? Let me see. Yeah, 83. And it is because it is capital S. So the other letters are simple. C, H, you have two O's and a L. So let's find out how C is referring. So simple C. Now where's the simple C? I saw some simple letters over here. Oh, there you go. Simple C is over here. So it belongs to 99, right? Then we need H, simple H. So you can see the sequence goes the same way. If C is 99, then D, E, F, G, H. So 99, 100, 101, 102, 103, and 104. So that is why I told you, if you know the decimal value of a number, it is easy for you to guess the other decimal values of the other letters. If you know a decimal value of a letter, particular letter, Then according to the alphabet, you can like move around the alphabet and guess what is the decimal value belongs to each and every character, right? So in the examination, they will give you a value of a one particular character. Then we'll ask you to find the code for the entire word, right? So that is the same thing that they have done over here, right? But here, since the capital S is involved, we have to find the capital S code separately. Yeah, Dihan, මේ දේවල් ටික කරාම පුතේ මේ lesson එක ඉවරයි. This lesson is going to end. So we have another 2 topics to go, EBCDIC and the Unicode, then it is done. Right? So in the example, they have taken C as 99, so H as 104 and O as 111. So we can see the relation, neither. So if C is 99, then how the alphabet goes? C, D, E, F, G, H, I, J, K, L, M, N, O. So C, if C is 99, D is 100, E is 101, F is 102, this is 103, and this is 104. That is how 104 is taken, right? Then it continues 105, 106, 107, and L is 108. That is how 108 is taken, and 109, 110, and 111. O is 111. That is how O is taken, right? So then what they have done is they have represented these values in 7 bits. Can you see that? This represents 83 in binary, and this represents 104. I'm sorry, 99 in binary. This represents 104 in binary, and this represents 108 in binary. Right? You must always use 7 bits. Right? 7 bits fill when in නැත්තම් දැන් ඔයගලන්ට 1 represent කරන්න කිව්වොත් 7 bits වලින්, so you are going to represent it as like how 0 0 0 0. There will be 6 zeros and a 1. Right? ඔය විදිහට තමයි එක represent කරන්න කිව්වොත් bit 7කින් represent කරන්න. Right? දෙක represent කරන්න කිව්වොත් it's going to be 5 zeros, 1 and a 0. Right? අපි normally represent කරන්නේ 1 0 කියලා විතරයිනේ. But since this is a 7-bit representation, you have to represent everything in 7 bits. So in case if you don't have the leading bits, you have to fill those things in from zeros. Right? So then the thing is simple. Here they have write the S in binary, and again C in binary, and H in binary, O in binary, and another O in binary, and finally the L in binary, right? But you won't be getting this big, these type of, like, you won't be getting big words for your examination. Sometimes you will be given the value of C, and you are asked to write the ASCII code of CAB. Right? So you have to represent C in 7 bits, A in 7 bits, and B in 7 bits. Right? And you don't need to by heart these values because it differs from paper to paper. Right? They are giving just a number. So only thing you have to remember is if they are asking you to represent it from ASCII, it is always 7 bits that you have to use. Right? Did you got the logic, people? Can I have the confirmation? Right, great. Okay, so I'm not going to do any exercises from this today. So by next week, we'll continue with some exercises, and we have another two representation methods. Plus, we are going to do we are going to start the fourth lesson, the logic gates, on the next week. It will be like within half an hour, I will be able to cover the other two coding systems, right? So get ready. And yeah, so the people who don't have the questions can leave the session now, right? Thank you very much and have a very good night. And I'll see you the very same time on next week. And for the people who are having the questions, you can stay. I'll solve out the things and go, right?
Right.
Thank you very much, everyone. For the yeah, thank you very much for the people who are leaving, right?